All right, let's dive right into this explainer and get the executive summary on how our planet's atmospheric and climate systems actually work. We talk about the weather constantly, usually just to complain about it, right? But today, we're stripping all of that down to the foundational mechanics. We're going to look at the exact science of what's happening right above our heads and how it directly impacts our everyday lives on the ground. We're taking a top-down journey today. So we'll start with the atmospheric blanket, clarify weather versus climate, break down the elements of weather, look closely at India's vital monsoon, and then finish up with our human footprint. Okay, Section 1, the protective atmospheric blanket. Let's start way up top with that vital blanket of air held to the Earth by gravity. Without this invisible shield pulling down around us, life as we know it simply wouldn't exist. Think about the exact mix of what we're breathing right now. It's predominantly nitrogen, an overwhelming 78% of it, and oxygen at 21%. But the really wild part? It's those tiny, almost invisible slivers, argon, carbon dioxide, and other gases that make up less than 1% combined. You'd think they wouldn't matter, but despite their microscopic quantities, these trace gases are absolutely crucial. They basically act as the planet's thermostat. By trapping the sun's energy, they stop our planet's heat from just bleeding back out into the freezing void of space, maintaining this incredibly delicate, highly sensitive balance that keeps the whole globe habitable. Now, think of the atmosphere like a highly specialized 5-story building. On the ground floor, the troposphere, that's where all our chaotic weather lives. Take the elevator up to the stratosphere and you found that smooth, cloud-free cruising altitude for airplanes, complete with the ozone layer that acts as our planetary UV shield. Higher up in the mesosphere, it gets incredibly cold, yet atmospheric friction is so intense up there that meteorites literally burn up upon entry, shielding the surface. Moving up to the thermosphere, this is where solar winds interact with gases to create those stunning auroras, and it actually reflects radio waves back to Earth so we can communicate. Finally, the penthouse, the exosphere. Here, the air is so incredibly thin and gravity is so weak that light gases just kind of float away into deep space. Well, let's leave the edge of space behind for a second and drop right back down through those beautiful clouds. We're descending back into the troposphere because this is where the complex daily dance of our weather actually happens. Which brings us to Section 2, weather versus climate. Once we hit the ground, we really have to clarify two concepts that interact constantly but are completely different things. People mix these up all the time, so let's lock down the executive summary here. The absolutely crucial point is time. Weather is the immediate hour-to-hour condition outside your window, whereas climate is the long-term, 30-year average of a region. Think of it like this. Weather is whether you need to grab an umbrella today because it's raining right now. Climate is knowing that you need to own an umbrella in the first place because you live in a region that gets a ton of rain over decades. Weather dictates your mood and what jacket you throw on. Climate dictates the entire ecosystem, local agriculture, and the long-term survival of species in that area. Moving on to Section 3, elements driving our weather. To understand the broader climate, we first need to look at the daily ingredients that drive our weather. It's a hugely dynamic system for sure, but it really boils down to a pretty simple recipe using just 5 ingredients. It all starts with temperature, driven by insolation. That's the incoming solar energy intercepted by the Earth. Drop in precipitation, which is just the atmosphere getting totally saturated and dropping water as rain, snow, or hail. Add humidity, the invisible moisture hanging in the air. Whisk in some wind, which is simply air rushing from a high-pressure area to a low-pressure area, trying to find balance. And finally, atmospheric pressure. Actually, think about this for a second. There is a massive weight of air literally crushing down on you right now. And the only reason you don't feel it is because your body pushes back outward with equal force. Pretty wild, right? Let's transition to Section 4, India's vital monsoons. Let's zoom in on a specific regional reality and see how these elements combine in a highly predictable pattern, specifically in India's distinct tropical monsoon climate. India's climate is so structured that it follows this fascinating historical timeline of 6 traditional seasons, deeply tied to the lunar calendar and agriculture. It flows from the spring of Vasanta through the intense summer of Grishma, straight into the vital rains of Varsha, and eventually cools down through shrouded Hemanta and Shishira. What's so remarkable here is the sheer mechanics of this ancient science. Historically, agricultural predictions for these seasons were so meticulous they were based on the exact positions of the moon and lunar mansions known as nakshatras. It was this ancient, highly accurate climate forecasting model,
built centuries before modern meteorology even existed, and millions of farmers still intuitively rely on its rhythms today.
The absolute critical engine of this entire cycle is the monsoon. Now, a lot of folks think a monsoon is just a really big rainstorm. Actually, scratch that. Fundamentally, it's a massive seasonal reversal of wind direction. During the summer, this giant thermodynamic engine kicks into gear. As the landmass heats up, the winds completely shift. They start blowing from the high-pressure areas over the cooler Indian Ocean and Arabian Sea straight into the lower-pressure heated landmass, dragging just massive, unfathomable amounts of oceanic moisture with them. And this perfectly illustrates why the monsoon is the true economic engine of the whole country. It dictates the water supply, food production, and millions of livelihoods. The vast majority of agriculture relies on this exact window for sowing crops. When the system works perfectly, reservoirs fill up, hydropower generates electricity, and rural employment booms. But nature has a really delicate balance. A weak monsoon brings devastating droughts that cripple the economy, while an overly intense one brings catastrophic flooding that can wipe out entire infrastructures. And that brings us to our final part, Section 5, the human climate footprint. Let's bring this science all the way down to the micro level. Because we aren't just passive observers sitting underneath this atmospheric blanket. Our actions on the ground are pushing back against the sky. Take the 2023 Punjab floods as a prime example of what happens when extreme natural weather collides head-on with human planning failures. Yes, the natural causes were incredibly intense. Heavy monsoon rains amplified by western disturbances that rapidly swelled major rivers like the Sutlej and the Beas. But the human-made causes? They tell an entirely different story. The damage was severely aggravated by weak, outdated embankments that were never designed to hold that kind of volume. It was worsened by short-sighted urban planning, with people building homes and farms directly inside natural floodplains, essentially creating a funnel for disaster. Add in the silt building up in poorly maintained dams, and you've got a perfect recipe for catastrophe. The weather event itself was completely natural, but the immense scale of the destruction, that was strictly human-made. So this brings us to a highly personal question to wrap up our executive summary. What is your carbon footprint? When we talk about global climate, it's so easy to just point fingers at large industries, but the mechanics of climate change involve every single one of us. Think of this like your daily scorecard. Every single choice you make carries an impact score for our climate. Are you walking or cycling to the store? Awesome, that's a low-impact 1 point. But if you're defaulting to a private car for a quick 5-minute trip, or you're constantly racking up frequent flyer miles, you're immediately jumping into those high-impact 3 or 4-point zones. The exact same logic applies to your electricity, leaving the AC blasting when you're not even in the room, or casually tossing single-use plastics into the trash instead of recycling. It might seem totally insignificant in the moment, but these seemingly small points accumulate across billions of people. Remember those trace gases we talked about at the very beginning acting as a thermostat? These habits directly thicken that atmospheric blanket with excess carbon dioxide, throwing that delicate balance totally out of whack and fundamentally altering our long-term climate. To conclude this explainer, I'm leaving you with a challenge, my climate action pledge. Think about just 2 simple changes you can pledge to make today to protect our shared atmospheric blanket. The climate isn't just something happening to us out of nowhere. It's a giant interactive system that we're actively participating in every single second of the day. So take a hard look at your daily habits. What score are you putting on the board today? And more importantly, how are you going to lower it tomorrow? Think about it.